All right, so we are back with another problem. Pseudo-palindromic paths in a binary tree. This is the problem of the day. And so we have been asked to find the number of pseudo-palindromic paths in the binary tree. What is a pseudo-palindromic path? Let's say if we consider this path, okay, 2, 1, 1. So at least one permutation of this path should be a palindrome. Okay, let's say if we go from 2 3 3, we can see that 3 2 3 is a valid palindrome. It is a permutation of this path and it is a palindrome, right? This path is a pseudo palindromic path. Okay, 2 3 1 is not a pseudo palindromic path. So by simple knowledge about palindromes, what do we know? Like we know that, okay, we know that, let's say if we have 1 2 3 and 4, okay, now uh, can this ever be a palindrome? No. Why? Because the number of odd occurrences of integers is greater than 1. How come it is greater than 1? Only 1 is present only once, 2 is also present once, and 3 and 4. So all these numbers, they are appearing odd number of times, and and not just one number is appearing odd number of times, more than one number is appearing odd number of times. So this is not acceptable, right? This can never be a palindrome. Let's say if in case we have 2 3 4 1 2 2 3 and 4. So over here you can see that the occurrences of 2 is even, number of occurrences of 2 is even, number of occurrences of 3 is even 4 is appearing 2 times, 1 is appearing only 1 time. So can any permutation of this string be a palindrome? Well, yes. Let's say if we start with 4, we go up to 3 2, 1 can be the middle one, and then 2 3 and 4. So this right here is a clear permutation of the above string or path, and it is a palindrome. So what is the criteria? The criteria for a path to be a palindrome is number of odd occurrences of integers should not exceed 1. They may be present or they may not be. What am I talking about? I'm talking about the integers that have odd occurrences. All right, so let's go on and code up the solution. Okay. hmm. Okay, let's just discuss one test case. Okay, one more test case. Let's say if we have 4, we have 4 even number of times, we have 2 2, let's say we have 3 3 hmm? and let's say we have 4, okay, sorry, not 4, let's say 5. Now you guys might think that this permutation of this path might turn out to be a palindrome, but it is not possible actually. Why is it not possible? It is because odd occurrences are greater than 1. Like 3 is appearing 3 times, this is one odd occurrence. 5 is appearing 3 times, this is another odd occurrence. So can these two ever let a path be palindromic? No. It is simple, right? If I just remove it, and let's say if I make some changes, 4, they will never form a palindrome, right? This is like simple visualization, right? We can clearly see that we won't be able to divide it into. right? Let's say if I make 5 here, so this 3 will be in the middle, okay? And if I remove this 5, so how many threes? So now if I reduce the number of threes and number of fives to even, right? I have made two threes and two fives from 3. So I can see that this turns out to be a palindrome. So odd occurrences, if an integer has odd occurrences and some other integer also has odd occurrences, then a they might not form a palindromic path. So I hope the explanation is clear, and let's code the solution. So a little bit of backtracking will be involved, so I'll explain, okay? So let's take a temporary string. All right, we will store the path, okay? Also the number of digits, I mean the digit ranges from 1 to 9, right? The numbers, they have only one digit and they are from 1 to 9, okay? Also let's just go through the constraints first. So we have up till 10 to the power 5 nodes. So we'll code up a solution that fits in this time, okay? So let's say if I have a string, also to store the counts of the integers that we have encountered in the path, we will have a vector, okay? We'll also pass it by reference. So we'll return, or we'll call a helper function. We'll pass the root, we'll pass the string and the vector, okay? Things will be clear when I code up the solution and let you guys know what actually I'm planning to do. So okay, tree node star root string temp vector int tempo. All right, okay. Now what should be the base case? Let's say if I encounter a null node, okay? Let's say if root equals null, what can be the palindromic path? There cannot be any palindromic path, so we return 0, okay? Now what am I planning to do? See, what I can do is I can store my path in this temp string, okay? And I can store the counts in this tempo vector, okay, for each path. Now since I want to store all of these paths and the counts of the digits that are appearing in path in one variable, I'll pass these by reference. And then after going back from this one to this one, what we can do is we can remove this one from the string and we can reduce the count of 1 in the tempo vector, okay? Since there are digits from 1 to 9, we can initialize this tempo vector for 9 blocks and we can initialize each block with 0, okay? Because initially there are 0 elements. I hope I'm clear on this, okay? For each number, right? Now let's say if I encounter, okay, let me just write the base case later. Let's write the let's write the pre-order. Why am I using pre-order? Because we are making paths, right? So I will include this node in my path first. I'll then go left, okay? And then from here I can go left and then I can return. I can go right to the right of this, then I can return, and then I can go to the right of this, and eventually you know how a pre-order traversal works, right? Okay, so what is that one case that we want to solve for the current root? We want to include this root in our path, right? So what we can say temp dot push back. What can we push back? The root value. Also, that I have included the current root value in my path, I will also increase the count, okay? So I'll say tempo of root value, tempo of root value -1 plus plus. Why am I doing -1? It is because जो हमारा हमने वेक्टर डिक्लेयर करा है वो 9 ब्लॉक्स का है, राइट? लेकिन जो इंडेक्सिंग है डेट विल गो फ्रॉम 0 to 8. ओके, लेट्स से अगर मैं रूट वैल्यू लेता हूँ और रूट का वैल्यू 9 है तो वो आउट ऑफ बाउंड चला जाएगा, राइट? क्योंकि हमारे पास 0 से 8 तक के इंडेक्सेस हैं. तो जस्ट टू कीप अ काउंट ऑफ नोड 9, लाइक हाउ मेनी टाइम्स 9 is appearing in a path, what I can do is I can reduce 9 or the root value by 1 and store it in an index that is less than the current value. Okay, we are doing in order to avoid the out of bound error. Okay, so now हमने we have included this in our path, right? Now what can I do? I will call on recursion to solve the rest of the problem for me. Okay, I'll say helper call for the left of root, with temp and tempo vector. Okay, then I'll ask recursion to bring out the answer for the right path. Okay, tempo. Now what is my function returning? My function is returning whether a path is palindromic or not. Actually it is not a boolean value, it is actually returning the count of paths. Okay, let's say if I come from 2 to 3, then for this tree there can be a number of palindromic paths. Let's say if I get 2 palindromic paths, okay, then I will add these 2 paths, right? Okay, let's say if I'm at 2, I will check for the palindromic parts to the left, palindromic parts to the right, and I'll add it up. Okay, so I'll say int left is equal to this, int right is equal to this. Okay, and what are we returning? We are returning left plus right. But wait, we have passed tempo and temp by reference. So what do? We might want to backtrack from the changes that we have made for a state, right? So we will say tempo dot pop back. Okay, and we will also decrement the values count. Okay, -1, minus. Why are we doing this? Well, let's say if I'm from 2, I go to the left and then again to the left. So the path is 2, 3, 3. Okay, now the count for 3 will be 2 and for 2 will be 1. But as I return back, I don't want this tree to be in my path. Why? Let's say if this 3 is still in the string of paths, and if I return without popping it back, I'll go to this one, right? The recursive call for the right part of the tree will be made. So the path will become 2, 3, 3 and 1. But this is not a valid path, right? So that's why we are backtracking. Okay, this should be temp. Okay, so now just a minute. All right, so I hope I'm clear. Okay, I'll do a dry run of this code. Okay, now so let's write the base case. Okay, let's say if we are at the leaf node, root of left equals null and root of right equals null. That means we are at the leaf node. Now what do we do at the leaf node? We first include it in our path. Okay, because the leaf node is also the part of path, right? So we say this. We'll also increment the count, tempo of root val -1 plus. Okay, and then we count the number of integers that are appearing odd number of times, and if that number is greater than 1, we return 0, or else we return 1, because we have found a palindromic path. So for, okay, let me just initialize the odd count variable int odd, count is equal to 0 for auto add I in tempo if I mod 2 equals 1. What do? We do odd count to odd count plus plus, right? Now if, let me just say it like this only, return odd count greater than 1. If it is greater than, return 0, otherwise return 1. As simple as that. Okay, so let's run this code. Okay, what's the issue? Yeah, so oh, okay, one more step. We forgot to backtrack from here as well, right? So we might want to undo the changes that we have made to temp. Okay, temp dot pop back, oh sorry, temp dot pop back and tempo dot, okay sorry, tempo of root value -1 to be decremented. Okay, let's run this code. See, now let's try and submit this code. Excellent. So now let me just explain what we have done. What we have done is we have created a string temp that will store the path for us, and this tempo variable, this vector right here, will store the count of the digits. Okay, the number of times a digit appear in a path, right? Okay, fine. What this helper function is doing, this helper function is returning the number of pseudo-palindromic paths for the given tree. All right, okay, now we are here. So let's say if our root is null, what do? We return 0, no pseudo-palindromic paths. Okay, then we come here, we include the current root in our path, and we call on to the left tree that, let's say, what is this line actually, what does this line actually mean? It means that recursion, if I have included the current value in my path, please go on to the left of the tree and find out the pseudo-palindromic paths. Okay, and similarly we are calling for the same to the right. Okay, we are asking recursion to find out the pseudo-palindromic paths to the right once I have included the current root value in my path. Okay, we are assuming that we already have this function with us. This is the magic of recursion, right? We don't have to think much. Okay, and if you guys have done in order traversal, pre-order traversal, then you might want to rethink that I have actually done a pre-order traversal over here. So you can have a clear look. If you have a clear understanding of pre-order traversal, then this is a simple cakewalk for you guys. Okay, so we have included this in our temp string and we have incremented the count. Okay, then this will return the number of pseudo-palindromic paths to the left and to the right, okay, of the current root. All right, and then we have to backtrack. Okay, we have to remove the changes that we have made to the variables. Why is it necessary to pass it by reference? We can even pass it by value, but in that case the copy of string will get generated, right, in every time. Okay, let's say if it is a O of n path. Okay, well, it is not possible, but let's say since we have n nodes, so extra space will be utilized, okay, for creating, and it might lead to TLE at times. Okay, let me just try doing this. Okay, let's say if I submit, see, So this is giving memory limit exceeded error. Okay, why? Because we are creating a lot of copies, right? We are creating a lot of copies. So to avoid that, we are passing it by reference. Okay, and this question is like pretty good if we want to practice backtracking and recursion at the same time. So once we encounter a leaf node, what do? We push it into the path, we increment the frequency of that digit, and we calculate the odd count. Okay, if odd count is greater than 1, we return 0, otherwise we return 1. As simple as that.